Hello and welcome back to my channel. Today we're gonna help me solve a little problem I had while changing out my light switches. I had decided to get these new smart switches, but when I tried to fix them inside my wall, I noticed that I have two problems. One, there are no screw slots in my wall cavity. Now, there are ways to fix this. I believe there are off-the-shelf adapters for that, but that brings us to my second problem. The distance between the two fixing holes on my switch is larger than the actual diameter of my socket, so the screws would end up outside the socket. This is especially problematic because my wall is made out of brick, and while not impossible, it's definitely hard to replace the socket with a proper one. So I thought this is just the kind of problem that a custom 3D printed part would be suited to solve. So I started sketching. There was not enough space to put the screws in, but I noticed that I could force the screws if I placed them at an angle. I immediately thought of a clip like this, but with a tilted axis, and drew some concepts until I was happy with the result. Afterwards, I began modeling this in Catia. As usual, I modeled rough surfaces for the switch and socket. Then I filled in the gap with my part and positioned the hole. According to the measurement, this hole would have been outside the part, but I just had to move it as close to the edge as possible. Unfortunately, this means that there will be a lot of tension when it is assembled. I make sure to design the whole axis at an angle to make sure the screw fits. Then I pattern the hole in a circle around the device axis to allow me to possibly use several positions for the screw if I need to. Next, I want to create a gap in between the two halves of the clip. This is so the clip can deform and not break when I screw it in. I want the clip to still be connected near the front face, but easily split towards the back. So I create a blend of two surfaces of different width and give it a thickness in a separate body, and afterwards I just use a Boolean operation to remove and create the gap. Now, what's left to do is to create radii wherever possible for a smoother transition, and generally polish the surfaces wherever I can. And maybe create something like a crush rib structure on this side. At this size, it won't have so much ribs, but more of a jagged surface, which is still better than being smooth. After I'm happy with my design, I export it to Cura. I duplicate and position the part, and I need to make one little change. This being a tall and very thin part with a narrow base, it is at risk of toppling over while printing. So I printed with a brim to help it stick a little bit better to the print bed. This takes 43 minutes, and after removing the excess, it's ready to be tested. This brim is pretty easy to remove, as you can see. I do have some defects on the part, but I'm not really worried about them since this is essentially a Rawplug that it's meant to be deformed. Now, if you don't know exactly what you're doing, please do not attempt this next phase. Working with electricity is potentially life-threatening and can damage your property. Before I start working, I always turn off the power from the circuit breaker and always make sure to test the wires before touching them. But as an extra precaution, I also use insulated gloves. Okay, now that we've got all that out of the way, smart switches, being electric devices themselves, require both a live and neutral wire to operate. And most people, myself included, don't have neutral wires in their walls where the light switches are. So the way to get around that is by bridging the neutral and live wire of the bulb that is attached to with a capacitor, which is conveniently provided in the box, along with a no neutral connection diagram. This will allow a little bit of current to always pass through, and thus completing the circuit and allowing our switch to operate. After attaching the capacitor, I then remove the screws from the current light switch I have. Test the wires to make sure none of them are live. I wrap the two Rawplugs with some rubber band to keep them in place, as they don't really have good retention features. Then I assemble the wires. I carefully slide the switch back into the socket and manually attach the screws so the Rawplugs don't fall off. Then I carefully screw them back in. This really takes a while doing it with manual screwdriver, but I don't want to use the electric one because I don't want to damage anything. I put back the top cover, turn back the power on, and test it. After I'm satisfied that everything works properly, I reward myself with the most satisfying peel ever. And that's been it. Thank you very much for watching. Don't forget to like and subscribe, and until next time.